So in this video we are going to discuss about mutual exclusion principle. This particular concept of principle is already should be familiar to you because we will be discussing this in our 30C classes and all, degree classes and all, and we'll be using this particular concept for doing some problems and all. So in theory it is actually very simple principle. You just have to remember a particular sentence. That is, if you have a molecule that possesses a center of symmetry, there will be no fundamental lines common in IR and Raman spectra. നിങ്ങൾ ഒരു molecule consider ചെയ്യുന്നു, if the molecule has a center of symmetry, there will be no common lines in IR and Raman spectra. അതാണ് നമ്മുടെ basic ആയിട്ട് mutual exclusion principle. Only thing you have to identify is whether that molecule is having a center of symmetry. Benzene എടുക്കാം, BF3 എടുക്കാം, അങ്ങനെ സെൻട്രോസിമെട്രിക് ആയിട്ടുള്ള മോളിക്യൂൾസ് എല്ലാം എടുക്കണം, അല്ലെങ്കിൽ CO2 എടുക്കാം. ആ കേസിലെല്ലാം mutual exclusion principle will be applicable and it will be simplifying your quest for IR and Raman lines. So if you have a IR active mode of vibration, that would not be active in the case of Raman spectra if that molecule is having a center of symmetry. നമ്മൾ നേരത്തെ water molecule കേസ് കണ്ടായിരുന്നു. Water molecule കേസിൽ it is not having any center of symmetry. So obviously there was some modes of vibration which was common in both IR and Raman. അങ്ങനെ center of symmetry അല്ലാത്ത molecules common ആയിട്ട് വരുന്ന vibration modes ഉണ്ടാകും. But in the case of molecules which is having center of symmetry, there will not be any common lines in IR and Raman spectra, common modes in IR and Raman spectra which are active in IR and Raman spectra. So, if you are considering carbon dioxide, as you all know, is a centrosymmetric molecule. C double bond O, double bond O. Center of symmetry under. And for this kind of molecule, simplest example is carbon dioxide. Carbon dioxide in the case, since it is having center of symmetry, some of the vibrational modes will be Raman active, but they won't be Raman IR active, and some will be Raman inactive and they will be IR active. So here you can see symmetric stretching, asymmetric stretching and bending modes. So ഇവിടെ നമ്മൾ രണ്ട് കാര്യങ്ങളാണ് മെയിൻ ആയിട്ട് ഓർക്കേണ്ടത്. ഒന്ന്, what is the condition for IR active and what is the condition for Raman activity for a particular mode of vibration. IR active ആണെങ്കിൽ change in dipole moment during that particular mode of vibration. Raman active means there will be change in polarization or polarizability. Change in polarizability during that particular mode of vibration. So, symmetric stretching in the case, it is Raman active but IR inactive. IR inactive means symmetric ആയിട്ട് stretch ചെയ്യുമ്പോൾ dipole momentൽ change വരുന്നില്ല, പക്ഷെ polarizability change വരുന്നുണ്ട്. And asymmetric stretching, it is Raman inactive and IR active. And bending mode is Raman inactive and IR active. So here you can see the various vibrational modes of carbon dioxide. Symmetric stretching, bending and asymmetric stretching modes ആണ് ഇവിടെ കാണിച്ചിരിക്കുന്നത്. So first one, symmetric stretching modes. ഇതാണ് നമ്മുടെ equilibrium point. Equilibrium point ന്ന് expand ചെയ്യാം, അതുപോലെ തന്നെ contract ചെയ്യാം ആ bonds symmetric ആയിട്ട്. So when it is undergoing a symmetric stretching ആകുമ്പോൾ when it expands to the both directions, CO bond രണ്ട് ഡയറക്ഷനിലേക്കും equal ആയിട്ട് expand ചെയ്യുമ്പോൾ ഇങ്ങനത്തെ ഒരു geometryയിലേക്ക് അല്ലെങ്കിൽ ഇങ്ങനത്തെ ഒരു ഷേപ്പിലേക്ക് വരും. Here there is the dipole moment is same. Dipole moment is same ആയതുകൊണ്ട് there is no change in dipole moment. When it is contracting also there is no change in dipole moment. അതുകൊണ്ട് തന്നെ this is Raman IR inactive. But if you consider the polarizability, you can see polarizability is increasing. Magnitude ഇവിടേക്ക് elongation നടക്കുമ്പോൾ കൂടുതൽ easy ആയിട്ട് polarize ചെയ്യാൻ പറ്റും. So polarizability will be increasing as you elongate the bond, and as you contract the bond, the polarizability will be reducing. ഈ minor axis ന്റെ അല്ലെങ്കിൽ ആ corresponding polarizability ellipsoid size നോക്കുമ്പോൾ നിങ്ങൾക്ക് മനസ്സിലാകും how much magnitude is changing upon this particular vibration mode. Symmetric stretching നടക്കുമ്പോൾ you can obviously understand that the magnitude of the polarizability is changing significantly. So that is Raman active. If you are plotting the polarizability versus the corresponding elongation or the corresponding displacement, you can get a graph like this. Raman active ആയിട്ട് നമുക്ക് observe ചെയ്യാൻ പറ്റും. But if you are going to observe the bending mode observe ചെയ്യുവാണെങ്കിൽ what you will be observing here, linear ആയിട്ടുള്ള molecule bending നടന്നു and രണ്ട് സൈഡ്സിലേക്ക് bending നടക്കാൻ പറ്റും. So ഇങ്ങനൊരു bending നടക്കുന്നു, ഇങ്ങനൊരു bending നടക്കുന്നു, and each of these bending modes will be providing a change in dipole moment. Dipole moment change ആകും, but you can see the corresponding polarization is not changing, polarizability is not changing. Almost same ആയിട്ട് തന്നെയാണ് നിൽക്കുന്നത് polarizability. So that is Raman inactive but IR active. And if you consider asymmetric stretching, in the case of asymmetric stretching, you can see from the equilibrium position, the CO, one of the CO bond length will be reducing and the other CO bond length will be increasing. So this one will be resulting in a small change in the corresponding polarizability and large amount of change in the corresponding dipole moment. Dipole moment large amount of change varum, പക്ഷേ polarizability വളരെ significant ആയിട്ടുള്ള change വരുന്നില്ല, small change മാത്രമേ വരുന്നുള്ളൂ. So that is Raman inactive, but it is IR active. So ഇങ്ങനെ നിങ്ങൾ consider ചെയ്യുമ്പോൾ it's clearly visible from these figures that symmetric stretching mode is IR inactive and Raman active, and other two modes are IR active as well as Raman inactive. So carbon dioxide, which is a molecule having a center of symmetry, will be having some vibrational modes which are Raman active and IR inactive, as well as some will be Raman active and Raman inactive, and those will be IR inactive. That is the molecules like carbon dioxide, which is having the center of symmetry, will be following the mutual exclusion principle. They will be showing the mutual exclusion principle. So ഇതൊക്കെ നമ്മുടെ പല പ്രോബ്ലംസിനകത്തും CSIR ക്വസ്റ്റ്യൻസിനകത്തൊക്കെ mutual exclusion principle related ആയിട്ട് ചോദിക്കാം. And first thing you have to identify is look is whether that particular molecule is having a center of symmetry. If it is having center of symmetry, then it will be easier for you to identify the IR and Raman active lines just by analyzing whether during that particular motion there is change in dipole moment and change in polarizability. So I hope it is clear, and that's all. Thank you.